Hello, my name is Rob Garner. I'm a computer programming instructor, and today we're going to look at interfaces in C Sharp. So I've got this program, and it's already got some code in it. It's got an employee class. Notice that this employee class is abstract, which means that you can't instantiate it directly. In fact, if we went to program.cs and I tried to instantiate just a generic employee, we should see an error occurs here. And in fact, we do get the red squiggles here. It says cannot create an instance of the abstract type or interface employee. So we have this abstract class. Now, why would we want this to be abstract? Well, we'll see that when we have an abstract class, it's really intended that you're going to inherit from this abstract class and make other concrete classes from it. And the reason why this is abstract is because pay summary is an abstract method, or actually an abstract property. It doesn't have an implementation for the get. It's just saying, hey, if you want to be an employee, you have to have a pay summary method. And then this pay method is also abstract. And this will be a method that you would implement that would have the starting pay period, the end pay period, and would calculate what the pay would be between those two periods. So because you have abstract methods, you have to declare the class as abstract. In fact, watch what happens if I get rid of that. We get, hey, it's abstract, but it's contained in a non-abstract class. So anytime you have abstract methods in a class, you must declare the class is abstract, and that means you can't instantiate it. And that makes sense from a practical perspective, as if you don't have these defined, well, how could C Sharp actually instantiate and execute anything on this class when it doesn't have any code defining it? We can see here that we have hourly employee, which inherits from employee, and as a result, it's got the pay summary property, and here it's defining this pay summary property by overriding it and actually providing a block of code to execute when we get this pay summary. And we also have implemented the pay method here. And what it does, it looks at the pay period, calculates the number of hours, and gets the rate. Now, where does it get the hours? Well, if we look at the employee class, the pay summary is abstract and the pay method is abstract, but the employee class comes with a list of hours. So we keep track of the hours no matter what type of class it is. The same way, but the hourly employee calculates the pay differently based on those hours by basically summing up all the hours and multiplying it by the hourly rate. The salary employee is very similar in the sense that it inherits from employee, but its pay method and its pay summary is different. It has different words in the pay summary, and notice that the hours are calculated differently. It basically just subtracts the pay periods, divides it by the pay periods per year, and multiplies it by the annual salary to get the pay for those pay periods. So a very different calculation. And this is why having this structure is helpful, is that we can have different employees with different pay structures, and we can have them all inherit from employee. And this gives us this benefit. So here we have an hourly employee. We've added their hours. And here we have a salaried employee. And we're going to display and then we have this method here to display their information. And it's going to take the start, the end pay, and employee. Now, notice that the argument for this method is an employee. Employee is an abstract method, but here we're going to call that display employee, that same method. In one case, you're passing an hourly employee. In the other case, you're passing in a salary employee. Well, how can we pass an hourly employee in one case and a salary employee in another case, and the method takes an employee? Well, That's because the hourly employee inherits from employee. So we say the hourly employee is an employee and salary employee is an employee. And because employee requires you to implement some version of pay, this works. Because here, when we say call this pay method, we know that anything that implements that inherits from employee will work. And this is called polymorphism in the sense that we can pass hourly employees or salary employees into this parameter. And since all employees have a pay method, we can be guaranteed that this code will work. So that's using an abstract class. Now, let's say that we wanted to create a phone book. And we wanted it to work with any kind of employee, but also we want to create a new class called department that will also be able to have phone book information. And so employees can have an email address and a phone number, but also departments can have it. But departments are very different things than employees. We wouldn't have department inherit from the employee class. So how would we do that? We want the phone book entry so that we can actually just have this list of phone information. Well, what we're going to do is we're going to use something called an interface. An interface is also a type of abstract class. And so I'm going to add a new item. And I'm going to pick interface here. And I'm going to call this one iPhone book item. So iPhone book item. Now, by convention, we start all our interface classes start with the letter I. And we're going to make this public. And it's going to have one thing in here. Get contact summary. And just like an abstract class, we're not going to provide a block of code. We're not going to do this. In fact, if we start doing this, it should give us an error. Yep. Not all code paths, well, actually say not all code paths return a value. But even this should, does this give us an error? It should. Well, in any case, interfaces are, by definition, abstract classes. So we don't need to use the abstract keyword here. But all the methods in an interface will therefore just be the function prototype without a block of code. And in other respects, they behave like abstract classes, except that you can't have any concrete methods in them at all. Now, why do we do this? Well, the reason why we do this in C# is that C# cannot have multiple inheritance. So what's multiple inheritance? Let's say we have a class A, and we have B that inherits from A, and C that inherits from A, and then D that inherits from two things. So let's say it inherits from A, B, and C. Well, let's say we have toString defined here and toString defined here. If we ask for D.toString, if we say console.write D.toString, well, which one would it go to? Some languages can handle that. C# does not. So by the way C# handles it, it says that you can only have one. You can only inherit from one other concrete class, or you can only inherit from one base class, but you can inherit from as many interfaces as you want. So because interfaces don't implement anything, there's no blocks of code in anything in an interface. You can have multiple inheritance from interfaces because they don't have any blocks of code. So the rule is basically you can inherit from only one base class in C#, but you can inherit from as many interfaces as you want. So now we're just going to use one, but you're going to see that in a lot of frameworks that support C#, there are instances where you have multiple interfaces that classes might inherit from. So we're going to create this, and then we're going to create another class. And this class is going to be called phonebook. And we'll make it public. And it's going to have a list of iPhonebook items. So those are interfaces. They're abstract classes, and we'll call them phonebook items. And then we will make a constructor for our phonebook. And we'll instantiate our list of phonebook items. And then the other thing it will have is a get method. And what this one is going to do is we're going to create an empty string for the phonebook. And then we're going to for each through each item in the phonebook. And we're going to say phonebook plus equals. And because we know that each phonebook item has a get context summary method, we can confidently know that every item that's in here, because if we look at iPhonebook item, we said it has a context summary method. We don't know what that context summary method does other than it returns as a string. And all we're going to do is we're going to concatenate that string with 2 carriage returns at the end of it. Combine it together and return it so that at the end here, we return the phonebook. And that's it. That's our phonebook class. It just creates a phonebook by going through all the phonebook items. So, okay, so let's close all these. And let's look at so how can we make phonebook items here? So we could make we could actually implement it off of hourly and salary, but one thing we could do is we could just say, hey, let's make employee inherit from iPhonebook item. And you'll notice that right away it gives us an error. Does not implement interface method get context summary. One of the neat things you can do is you can go to quick actions and refactorings in Visual Studio and say implement interface. And it will actually stub out to the method you want. And the nice thing about this is it gets it spelled correctly, has a proper return type, and it will stub it out starting off with throw new not implemented exception. You just replace that with the code you want. So in this case, what do we want our context summary to be for an employee? Well, we'll just return first name plus space plus last name. Maybe we'll add in a carriage return. plus on the next line, we'll put in the phone number. And we'll add in, so we'll need a phone number. So let's add those properties up here. So we'll need a phone and we will need an email. So we'll add two properties for that in the employee class. And then that way we have a phone number to add. So we'll make it plus the phone plus a carriage return. Plus, we're just going to concatenate all this stuff together. And then the email on the next line. And just, yeah, that would be it. So we'll have a nice little summary of for the employee. And then in program. So once we have that, in program.cs, let's put at the end here, we'll display the phone book. So now we can say phone book PB is equal to we'll instantiate a new phone book. So we're going to add the hourly employee and the salary employee, and then we'll just write, I'll put the phone book. So because hourly employee and salary employee, so wait, we didn't implement anything in hourly employee or salary employee related to the phone book. But because they both inherit from employee, and because employee has defined, phone and email and get contact summary for both of them, then it will work. And now one other thing we need to do is when we create our hourly employee, now we need to also provide the phone and the email. And the same thing here. When we create them, we need to now provide them a phone and an email. They both have that by virtue of being employees, inheriting from employee. And our phone book, now because employee has implemented iPhone book, we can therefore add our hourly employee or salary employee to our phone book items. And if we run this, there's our phone book. In fact, we can make this a little bit better by maybe doing that so that we can have a little heading. So we got 2 employees, and then we got the phone book that's working. Okay, now that works. The next thing we're going to look at is, let's say we want a class to represent each department. So I'm going to go into here and add another class called department. So this is going to be a class that we use to keep track of department information in a business. We're going to make it public. And we're going to make some properties for this. The name of the department. There's going to be an employee, which is going to be the manager. Yeah, we could do that. We could have a list of employees. Let's keep it simple for now, though. And we'll have a phone number and email for this one. And then also we're going to, let's do this, implements phone book item. And we'll implement the interface. Get an email. Maybe we'll have a website. And this will just be return. So the contact summary for this one, the thing that we want to show up in the phone book will just be this plus name. We'll hold off on the manager for now. Phone, email, and website. Actually, let's see what that would do. And then over here, we will make a constructor. And so I'm using some optional parameters here with some defaults so that if it's not provided, it'll provide some temporary stand-in. So I want the email, I want the website, and let's see what else we want. I think that's it. So we have constructor, requires it, department has to have a name when you construct it, but the rest is optional. And we have a contact summary. So can we use this in the in our phone book? It's not like the employees. The question is here, when we get to the bottom here, we add phone book items. Can we add it? Well, let's give it a shot. We've got that class. We'll make a department. And we'll make it be the sales department. And let's see if we can add it here. Phone book dot phone book items dot add department. And let's run it. And there it is. It just shows up. So the neat thing is that these two are employees we added to the phone book. And department, a very different thing, also could be added to the phone book. How can we add these very disparate things to this phone book? Well, again, it's employing polymorphism. All of these classes implement this iPhone book item interface. An abstract class with an abstract method get contact summary. The phone book class depends on everything in its list being iPhone book item. Because they're iPhone book items, they have a get contact summary method automatically. Get phone book doesn't care what you are as long as you have this method. And it'll just loop through and just call that method to get the contact summary and create this phone book. And then we can see that all employees are iPhone book items because they have that get contact summary. And departments, our department class works as well because it has this get contact summary. And so that's why, so that's the power of interfaces is we can have now we can have this one phone book class, one list, which is of iPhone book items. All these different things can be added to it, and it will still work fine because they're all meeting this contract requirement that they have this method. They don't care what this method does as long as it returns some kind of a string, and it will work. So that saves us a lot of code. If we didn't have that, we would have to have a lot of if statements. We'd have to have a lot of conditionals and checking and validation. Instead, it just works. So this is the power of interfaces, and you'll find that they're used heavily in C#. They're often used by programmers making libraries for other programmers. So they'll often put in these interface requirements for the methods they're using. And then if you implement those interfaces, you can then use those classes that they've made that are just dependent on the fact that they have an interface. There's a principle called the interface segregation principle, which basically says also try to make your interfaces have the least requirements necessary, keep them as small as possible, because then they become more generally useful. It's better to have several small interfaces than a few really big interfaces. It makes it more flexible and easier to adapt to different solutions. So that's that's the summary of what C# interfaces are. Thank you very much.